This is 5.5, first differences. We're on page 272. I'm going to have Justin, in the second row, to read. He's taking a little nap there.
Immediately after jumping from an airplane, a skydiver falls towards Earth with increasing speed. How can you tell if the speed is increasing linearly or non-linearly over time? In Chapter 2, Relations, you learn how to identify linear and non-linear relations through graphing. In this section, you will learn how to use tables of values to identify the type of relation.
All right, you guys remember Chapter 2? Remember we had the scatter plots. How could we tell if it was linear or non-linear? Michael?
Just going upward or downward, like positive or negative.
Linear or non-linear? No. Sebastian?
Using a line of best fit.
Yeah, we used that line of best fit. If it fit into a line, it was linear. If it didn't, it was non-linear. Remember that, Michael? Okay. So, method 1, it says use pencil and paper. Consider the relation y equals 3x. Copy and complete the table of values. So, let's finish this off. If x is 0, y is 0. If x is 1, I'm going to sub in 1. I get y is 3. If x is 2, what's y here? 6. If x is 3, 9, and 12. All right, there's my graph. Graph the relation. 0, 0, 1, 3, 2, 6, 3, 9. I get a graph that goes straight up like that. Classify the relation as linear or nonlinear. What do you guys think?
Non-linear.
Nonlinear? What? Why, Nicholas? Because of my bad graph? It's linear. Okay? If you were to draw it on a better grid, you'd see it's linear. Okay? Straight line. All right? Take my word for it. Describe the pattern in the x values. Add a third column to your table to record. So what's the pattern in the x values? This is really important. I touched upon this before about independent values. Look at the back. What's the pattern? Okay, good. It goes up by ones, but more importantly, it's consistent. It goes up by a consistent. It always has to be the same. It doesn't have to be 1. It could be hundreds, 20s, but it has to be the same. Okay? So the increments in the x values for any of this to work that you're learning today has to be the same. Okay? Can't go 1, 7, 10. Again, that's an indication of the independent term, right? They're always going up by the same value. All right. Add a third column to your table to record the change in y. Calculate each by subtracting consecutive values of y. All right, let's do this. So here's our table again. 6, 9, 12. So now this column here, we call it our first differences because it's the difference in our y value. So you always take y2 and you minus the previous y1. So here, 3 minus 0, 3. 6 minus 3, 3. 9 minus 6, 3. 12 minus 9, 3. The values in this column are called first differences. So there's your definition. Differences between consecutive y values in tables of values with evenly spaced x values. So if you're writing that definition on the test, that will be a key word there. Evenly spaced x values. What do you notice about the values in the third column? Right? They're the same? All right. Let's see. Repeat steps 1 and 2 using a table of values and the x values shown. All right, let's do it for this one. So x is 0, y is what? X is 1, I'm going to get negative 2 plus 7, 5. X is 2, I'm going to get negative 4 plus 7, 3. X is 3, I'm going to get negative 6 plus 7, 1. X is 4, I'm going to get negative 8 plus 7, negative 1. All right, now we're going to do first differences. Okay, and I like to put the box right in between. Okay, some people will put these arrows like that. All right, so 5 minus 7, negative 2. 3 minus 5, negative 2. 1 minus 3, negative 2. Negative 1 minus 1, negative 2. All right, all the same. Okay, the next one, I'm going to tell you, they're all the same. Okay, I'm going to spoiler. They're all the same. All right. Use first differences to determine, make an observation regarding linear relations and first differences. So what's the pattern? If the graph is linear, what are the first differences? Henry?
All the same.
All the same, right. That's the pattern. That's the whole idea from today's lesson in 5.5. The whole idea, if your first differences are the same with regular intervaled x values, everyone understands what that means, right? With all your x values increasing with a regular interval, if your first differences on your y's are the same, guess what? It's a straight line. Okay? Guaranteed. You don't have to graph it. Check your first differences. If they're all the same, it's a straight line. Okay? So use first differences to determine which of these relations are linear and which are nonlinear. So let's do it. First differences go here, remember? 3 minus 7, negative 4. Negative 1 minus 3, negative 4. Negative 5 minus 1, so negative 5 plus 1, negative 4, right? Negative 9 plus 5, negative 4. So this guy, linear or nonlinear? Linear. Good. This one, negative 1 minus 3. Sorry, minus 3, so plus 3, so that's 2. 3 minus 1, so 3 plus 1 is 4. 9 minus 3 is 6. And 17 minus 9 is 8. This one? Non-linear. Negative 5 minus 10, so plus 10 is 5. 0 minus 5 is plus 5 is 5. 5 minus 5, 5. Linear.
So it's not linear.
It's not? Oh, good. Nice. Thanks. Yeah, I missed it. Tricky. This one's going up by 2s. This one's going up by 1s. Yeah, I missed it. This one is going up by 3. No, it's going up by 3s. It is linear.
I looked at it wrong.
Damn, come on. No, it was a good observation, though.
But people agreed with me.
No, it's good, because it tells me that you're looking at that. That's very important. Good. Excellent. Write a rule for using first differences to determine whether a relation is linear or non-linear. Here's the rule. If first differences are the same, it's linear. If they're not the same, it's not linear. There's your rule. Describe how you can tell if the equation of a relation represents a linear relation. Describe how you can tell if the equation, here's our equations, represents a linear. Oh, we didn't do these two, and I said they were linear. They're not linear. My mistake. I just looked at them now for the first time. I thought they were just other examples, but if we were to do this one, so here y equals x squared. If we were to do this one, watch what happens. Y is 0, y is 1, y is 4, y is 9. Right? I'm subbing in these values for x. Now I do my first differences. 1, 3, 5. So this is nonlinear. And here's my other one. Y equals 2x. So again, x and y. 0, 1, 2, 3. Now I sub in my values. So I get 0 to an exponent. Sorry, 2 to the exponent of 0. I don't think we've learned this yet, but it's 1. Oh, we did learn this? Okay, sorry. Or you guys just know this? Did we learn this? Exponent of 0? It's always 1, the value. 2 to the exponent of 1 is 2. 2 to the exponent of 2 is 4. 2 to the exponent of 3 is 8. These differences, 1, 2, 4. So So these are nonlinear. Okay? So, back to the question. Describe how you can tell if the equation of a relation represents a linear. So of these three equations, which one represents linear? The top one, right? So how can we tell? What's the rule? AJ?
There's no exponents in it.
Excellent. So x is by itself. There's no exponent. There's no square on x, and it's not in an exponent. Okay? This is called a quadratic when it's x squared. And this one is called exponential when your x values is the exponent. Okay? So neither of these work. This is also not linear. This is not linear. Okay? All of these have their own graphs you're going to learn in grade 12. Okay? The ones we're interested in is any combination where the biggest exponent for x is just 1. Okay? Anything like this or like this, these are all linear. Okay? So that's your pattern. So if I were to ask you, is this equation linear? If this equation's linear, yes or no? AJ? No. Is this equation linear? Yes. Okay? Alright. And you can check that with the first differences. Key concepts. To work with first differences, the values of x, independent variable, must change by a constant amount. Very important. To find first differences, subtract consecutive values of y, dependent variable. I like to put them in the middle. This one's putting it in line there, but whatever. You're subtracting that value and getting this. If the first differences of a relation are constant, the relation is linear. If the first differences of a relation are not constant, the relation is nonlinear. Okay, also, x is linear, x squared is not. Okay, also for equations, x is linear, x squared is not, or any variation. Any questions?